Hi, welcome to my channel. This video I am going to explain about finite dimensional problems. Already in my previous video I have explained about basis and dimensions. Now it is in terms of finite dimensions. So let us get into the video. If S is a subspace of V4R generated by the vectors 1, minus 2, 5, minus 3, 2, 3, 1, minus 4, 3, 8, minus 3, minus 5, then the first question is find the basis and dimension of S. The second one is extend the basis of S to a basis of whose space V4R. That means S is going to be the subspace and it is a finite subspace because it has three vectors. Now we need to find out the basis for the finite subspace as well as we need to extend the basis of S in terms of whose space is going to be V4R. So the solution is I have given step by step so that it could be very easy to follow for you. So the first step is that the given vectors are going to be three vectors. Let us take it as V1, V2, V3, where V1 is 1, minus 2, 5, minus 3, and V2 is 2, 3, 1, minus 4, and V3 is going to be 3, 8, minus 3, and minus 5. So these are the three given vectors which forms a subspace S. Now the first step is let us form a matrix whose rows are these vectors. So I'm going to make these three vectors in terms of a matrix and which are acting as a row. So the first vector is going to be the first row, the second vector is going to be the second row, and the third vector is going to be the third row. Then the step 2 is I'm going to apply a small elementary row transformations, and then using the transformation R2 is I'm changing the row 2 as R2 minus 2R1 and R3 is going to be R3 minus 3R1, so that by doing so I am getting the matrix as 1 minus 2, 5 minus 3. The second row only I have changed. So the second row is being changed after applying R2 minus 2R1. I am getting it as 0, 7, minus 9, 2. And similarly R3 I am changing in terms of R3 minus 3R1. After the change I am getting this row as 0, 14, minus 18, 4. Now next is I am going to change R3 is going to be in terms of R3 minus 2R2. So if I change R3 as 2R3 minus R2, I am getting the third row as 0, 0, 0. That is all the elements in this rows are going to be 0. So step 3 you will understand why I need to do all these things. So here let us count non-zero rows. So if I count non-zero rows, there are two rows. The first is and the second one. The third one is completely 0. So it has only two non-zero rows. And hence we say that the dimension of S is equal to 2. So this is another way of finding out the dimensions. So to find the dimension, I am bringing that matrix in terms of echelon form, and hence I am able to find out two non-zero rows, and that determines the dimension space of the subspace S. So now let us write the basis vectors. So the basis vectors form the echelon form. The corresponding basis vectors of S are the first two rows of the echelon matrix. So what are those first rows? That's going to be 1, minus 2, 5 and minus 3, 0, 7, minus 9, 2. So these two vectors are going to be the basis vectors. And now so we get the dimension is going to be 2 and the basis vectors is going to be these two vectors, and the basis of S is these two vectors, so which forms as a subset. And now the next question is that we need to find out the extended basis of V4R. So as V4R is a 4-dimensional vector space, its basis will have 4 linearly independent vectors. It's a finite dimensional and has how many elements present in that determines the dimension. So there are 4 vectors are present in terms of 4 elements, and hence the dimension is going to be 4. And now already we have 2 from the subspace S. 2 vectors we found out. So if I add 2 more, then it will become 4 linearly independent vectors. For that, to make it as a basis for R4, add 2 more linearly independent vectors. Example, the standard basis, let us add the standard basis vector so that nothing will get affected. So E3 is going to be 0, 0, 1, 0, and E4 is going to be 0, 0, 0, 1. You know that all standard basis E1, E2, E3, E4. I am adding 2 more vectors to the existing vectors, and hence the basis of V4R will become 1, minus 2, 5, minus 3. That and next one is going to be 0, 7, minus 9, 2, and the third vector is your E3, and the fourth vector is going to be your E4. So the basis has 4 vectors, and hence we can conclude the result as basis of S is going to be 2 vectors, that is this set. 1, minus 2, 5, minus 3, 0, 7, minus 9, 2. So this is going to be the basis of S, and dimension of S is going to be 2, and the extended basis of V4R is all these 4 vectors. So this is the solution. Thanks for watching. See you in the next video. Please like and subscribe for more videos.